Hi everyone. So I think everyone knows me, but if you don't, my name is Lily. I'm a software engineer on the core components team, and I'm working with Ollie, Shemek, and Jonathan. And today I'm going to be talking to you about undoing changes in Git and rewriting history and what that actually means. So first of all, I just want to touch on a few basics because there are a couple of things that are quite important in order to understand what undoing history really means and what is rewriting history. When you run, it's a bit laggy. Come on. So when you run git init for the first time in the project, it creates a .git directory. So if you have a look inside, what you will see is that you have something like this. So you'll have head, config, description, hooks, info, objects, and refs. You might actually have more than this, but this is what you're likely to see by default. So this is where most of the things that Git uses are. So it will store almost everything here that it manipulates. So let's have a look at Git objects. Okay, so Git uses a simple key value store, and Git stores all of the content using either trees or blobs. So a tree can be thought of as kind of a directory, and blobs are bits of content. So a couple of other examples of objects are commit and annotated tag. So what are refs when it loads? So ref stands for reference, and it is kind of a user-friendly alias for referencing a commit hash. So each commit actually has a commit hash, and you can get the commit hash directly by looking at git log, but refs is an indirect way of referencing that. So this is actually Git's internal mechanism for referencing branches and tags. So next up is head. So when you create a new branch, Git uses the last commit of the current branch as a reference, and it will apply all your new commits on top of that. And how does Git know what the last commit is? It actually uses the head file to store that information. So the head file is a symbolic reference to the branch that you are on. And what that means is that it's actually just a pointer to an actual reference. It is not a commit hash or anything else. So let's have a look at what undoing stuff actually means. So first of all, just a huge warning, do not undo or amend public code. So anything that has been pushed, don't even go there. Unless you really know what you're doing, that is not something that you should even attempt. So it is very important to know this because there may be mistakes and they will be very difficult to recover from. So what do we mean by rewriting history? So when you rewrite history, what you're actually doing is you are creating a brand new commit. And the old commit that you have rewritten, undone, or removed is actually completely erased from history. This is why it's really dangerous to actually amend anything that's already been pushed, because if somebody bases their work on the commit that you have just erased, it will look like it's just vanished for them. So let's have a look at some examples of what kind of things you can do to amend or undo things. So example one, let's say you forgot to branch. So what you can do in that scenario is you can use git reset -- soft head, and what that will do is it will unstage all the changes you've just committed. They will still be there, so you can then either create a new branch or do whatever you need to do to the code and carry on from there. So let's say now you want to amend the last 3 commits, or 4 or 5 or even 10. So you can use git reset head and then the number of commits that you want to go back. And what that will do is it will unstage that number of commits from head. So the changes are still there. And once again, you can either create a new branch or remove or do whatever it is that you need to do. So let's say you made some changes and you really didn't want to do those, or for some reason you decided that it's not worth it. You can actually undo all of that, and you can use git reset and the path to the file name that you want to reset back to how it was, and it will restore the file to the latest version in the head. And once again, the changes are still there, so you can still do something with them if you want. If you have done something to the file beyond recognition and you just really want to go back and you don't want to save, maybe you've experimented, maybe you've completely screwed up, you can just check out the file and it will get the latest version stored in the head. It will not store any of your changes. So if you want to store the changes, you should use reset instead. So let's say that you have found a bug. Yes, sorry.
Is that equivalent to git reset hard?
No, soft is something else. Sorry? Oh yes, sorry. Is it the equivalent of git reset hard? I'm not entirely sure what hard does, but soft unstages the changes. I think hard does something quite different actually. I think it does it to the remote instead of local.
I think it's still local.
Yeah. What's the difference? It doesn't keep the changes.
I thought soft keeps when you're working copy and hard just gets stuff.
Yeah.
So it's the same as doing a checkout.
Yeah.
Yeah.
Huh. Okay. So yeah, so next, let's say that you had something that was buggy and you have discovered exactly at what point the bug was introduced and you want to undo that commit. You can revert the commit. And what that actually does is that it actually creates another commit, which does the exact opposite of the previous commit. So this doesn't amend history. It just actually creates a new commit on top to undo what you've done. So let's say you didn't mean to commit just yet, or perhaps you made a spelling mistake in your message, or you forgot to add a file. You can use git commit amend. So what this will do is it will actually open up the last commit, and it will open up the last commit, and it will let you edit the message. If you want to add a new file, what you can do after you've committed is you can do git add file name as normal, and then when you do git commit, just use -- amend, and that will add the file to the previous commit. If you use -- no edit, it will take the last commit's message and it will just add the file in. If you did want to amend the message because the new file you've added maybe has changed what you want to say, you can just do git commit -- amend without the no edit, and that will let you add the file and edit the message as well. So, rebasing. So this is something that you can use instead of merging. So this is a cleaner way where you can tidy up all of your code before you push it. And what does rebase actually do? So rebase moves your branch onto a new base commit. So what that means is it's going to lift up all of your commits on your feature branch. It's going to take whatever the base that you have set for it to be. It will apply all of those commits first, and it will apply your commits from your feature branch one by one on top of it. And if there are any conflicts, it will ask you to resolve them there and then. So you will still get conflicts if they're there. And we'll talk a little bit more about that in a sec. So rebasing onto master, as an example, will take, this is probably the most common use case. So you're working on your feature branch, somebody has pushed something new to master, you want to get those changes before you push so that you don't have any merge conflicts. You're going to rebase onto master. And then that way, it will take all of master commits and it will apply your commits on top. So to try and visualize what that actually means. So imagine this is your feature branch here, and then we have master here. And maybe imagine there was a new commit as a circle here that has come in. So what it's going to do is it's going to just replace all of this with whatever the new master is, and then on top of it, apply your feature. So it's a bit more of a linear history. And here's another example of what that might look like. So before rebase, as you can see, you have your feature and your master kind of separate. After rebase, your feature directly follows on from master. So this is an interactive example that we're going to have a look. So I advise using the -i, so interactive rebase mode. So this will guide you through, and especially if you want to make changes, this is what you want to use. So let's say you want to squash things, maybe you want to delete things, maybe you had a mistake in one of the messages and you want to amend what you've said, reword it, make it look nicer. So you should be doing all of this before you push. So what you can do is this is like tidying up. You should do this frequently as well, because just like merging, if you leave it till the end, you're going to have a huge merge, you're going to have lots of merge conflicts, and it's going to get really long. So here I have 3 commits that I've done on the feature branch. And what I'm trying to do is I'm trying to rebase all of those onto master. So what that means that for example, there was new commits on master, there was a new feature, somebody pushed new code, and before I push, I want to get all of that new code to make sure that my code is up to date. So what we're going to do here is when you enter interactive mode, you see that it has some information here on what you can do. So you can pick, which will just use the commit as it is and apply it. You can reword, so it will use the commit but let you amend the message. You can edit, so you can edit your commit, add a file, remove a file, edit the message as well. You can squash. This is an important one and quite useful. Sometimes we all have silly commits like fixing linting or something rubbish like made a mistake. You can squash those commits so that they're not separate and you can add them to the previous commit. Oh, you can't see stuff now. We have fix up, which is like squash, but discard this commits log message. We have exec. It's a bit advanced, so if you want to run a certain command at some point, you can use that. And you can drop, so you can remove a commit. So maybe there's a pointless commit in there. So let's do an example. So what we're going to do is we're going to squash commit 2 into 1, and then we're going to edit commit 3. So what I've done here is I have actually edited, instead of P for pick, I've used S and E. So the commit that I want to squash, I have changed pick for S, and the commit that I want to edit, I've put edit next to it. So you just edit this as normal, and then you save, and then, yeah.
Do you mind if I just splice it?
Yeah, absolutely. Zoom in. You can't see.
No, we can't see that for any future request.
Okay. Okay, so after we've saved the options that we've set, the first thing it's going to do, because we've left the first commit as pick, it's not going to give us the option to do anything there. For the second commit, we've put an S, saying that we wanted to squash it into the first commit. Squashing always does it into the previous commit. So now that we've done the S, you can't read anything, but what it says here is that it says that this is a combination of 2 commits, and it says the first commit messages, and it says removed an active toggle state, and the second commit messages bumped base CSS package version. So what you can do here is you can now edit this message. So you can just maybe create a new combined message, or you can leave it as it is and carry on. And what is done at the bottom is that for changes to be committed, it's actually added the other file that was in the second commit into the first commit.
When you had the 3 lines at the top,
Yes.
is it the newest commit first or the oldest commit first?
Oldest commit first. So what I've done in here is I've actually reworded the message so that it's more useful when there's both of the commits merged together. And I'm just going to save as normal. And after that, it's actually going to, so saving here. And after that, it's going to go on to the next step. So for the next step, it's actually told us, we've told it that we want to edit. And so it's now showed us what it's done. So it's done the removed an active toggle state and bumped the CSS package version. So it's now 1 commit. At this point, it's detached the head. So what that means is when you're rebasing, it actually detaches head and it starts doing all this stuff. So if at any point you need to escape, and for some reason you have a meeting or whatever else, you will want to actually quit rebase properly. There is like a rebase abort command. Don't leave it in this state. Otherwise, you'll have to come back and remember that you were rebasing and actually continue. So what it's doing now is that because I said I want to amend, it's going to let me amend the next commit. So it just takes me back to the mode where I can actually make the change. And what I've done in the amending the commit, I just changed the message again and I saved. And after this, it just takes you back to sort of normal. You know, you need to pay attention here. It will say that you want to carry on the rebase. You have to manually say that I want to git rebase dash dash continue, because it lets you go and add files, remove files, do whatever you normally would do. It is still in this interactive state. You need to tell it that you're done and you're continuing. So after we do git rebase continue, we are actually finished because we have squashed our second commit and we have edited our third commit, and it is done, and it will tell you that it's successfully rebased, and that's it. So a couple of things to help you with rebase. So first of all, there's this really handy feature called re, and you really want to enable this. It stands for reuse recorded solution. It's not only useful in case of rebasing, but it's useful in case of merging. And what it does is every time you have a merge conflict or a rebase conflict and you record a resolution, it will remember what you did. So the next time the exact same conflict happens, it will automatically apply your resolution. So when you're rebasing, the next time you rebase, it's actually going to show you the same conflicts again, because all you're doing is that you're lifting your commits from your feature branch, you're applying an entire new base, and then you're applying them one by one. So if you had a conflict in a certain file and you didn't record a resolution using re, it will ask you once again to record a resolution, which can get pretty tedious pretty quickly. So enabling this, you do it once and it's forever recorded and remembered. So yeah, so you can just add it as a enable the get config and you're good to go. So the next useful thing is something called git ref log. So it is just a reference log. And what it does is that it records the tips of branches and other references that were updated in the local repository. So if you want to find out what you've done, or what commit was what, or what the commit hash was of a certain commit, or when you checked out something. So it's literally a very specific history of everything that you've done. So this is where you can go and find out to which state you want to revert to or what you want to undo. So you can't read this, but you will see that it has everything from when I merged something in, when I checked out a branch, when I pulled something, like everything. So a couple of takeaways. So because of how rebase works, you do not want to mix rebase and merge. You should just use rebase, or you should just use merge before you push your code. So rebase is obviously a nicer, cleaner way to later present your code when you push it, because you can tidy up anything that might be a bit messy, anything that was a rushed commit, anything that was unneeded later on, and any mistakes. So you should ideally just use rebase. It may be a little bit scary at first, but if you just try it on an example branch that you don't care about, make some changes and try rebasing, you'll see that it actually guides you all the way. And if you just read the messages that it tells you, it's not that bad. So yeah, only rebase before pushing your code, ever. And then you can rebase multiple times, just like you would constantly merge. Whenever there's a new change, rebase. Yeah, and so once again, only undo and amend things locally. And that's it. Thank you. Yes.
Should you use stashing and popping as well?
Sorry?
What about stash and pop? Does that tie into this as well, or could that tie into
It could. So I only ever use stashing. I have not used popping. I only ever use stashing if I've made some changes. I'm unsure if I want to keep them, or I'm unsure where they need to go, and I need to check out to another branch to maybe find out what's going on there. I would stash the changes then. So you do git add, git stash, check out, do whatever you need to do. And then when you come back, you could just do git stash apply, and it will just apply your stash again. So I think it's only kept for a certain amount of time as well. So eventually you will lose the stash. So you just need to remember that you need to keep it. I haven't used popping.
Well, so yeah, but to sort any merging issues you could have. So the first point you had, don't mix rebase and merge.
Yeah.
Sometimes onto a stash, rebase, and then apply the stash.
Okay.
So you bypass any potential merging issues.
Okay, but then you can just apply the stash, do a commit, and it will just be on top of what you've already rebased. So that would be clean. Any more questions? No? Cool. Thank you.